Let us try to understand what a vector is in 3 space. So here I have some points which you should copy down and understand. These are the terms which we will be using from now onwards. Vectors in 3 space are 3. Representing algebraic vectors in 3D space. Now when we say algebraic vectors, then we are trying to give a coordinate point to it, right? Earlier you were seeing geometric vectors where we had drawn some diagrams like arrow diagrams, correct? So this arrow diagram represents a geometric vector. It could represent vector in 3 space also, correct? The velocity problems which we did, the force problem, the tension problems, and relative velocity, in solving those problems we took help of geometric vectors. Now algebraic vectors, when we talk about in 2D or in 3D, we try to give their coordinates so that we know the points from where they start and they end, and that helps to do calculations. So algebraic vectors help us to calculate and to manipulate and to solve problems, correct? So that is what algebraic vectors are. So let's see how to represent algebraic vectors in 3D space. When we say 3D space, we also use the term R3, which is 3 dimensions, okay? And these dimensions we normally will take along x, y, and z axis. A point P in 3D space is identified with the coordinates a, b, c, where a, b, c belongs to real numbers. So that is exactly like what we had in 2D space. In 2D space, the coordinates were 2, right? A and B. A along x-axis and B along y-axis. Now here we have z-axis also. So we have a triple here, right? Instead of a pair which we had there, we have a triple here. So instead of a coordinate pair, we call them as ordered triple. Now, next point is, position vector OP is drawn with tail at the origin and head at point ABC using rectangular prism. Now in 2D also you saw that we could draw position vector with point beginning tail at the origin and the head at the defined point OP, right? So here we have R3, so 3 dimensions. So we call these as direction numbers also. A, B, and C are your direction numbers along x-axis, y-axis, and z-axis. Any vector in R3 can be written as an ordered triple. Vector u equals to ABC in square brackets. So this is what we call as ordered triple. The components A, B, C are called direction numbers. So it's very important definition here. So the coordinate points A, B, and C, we call them components A, B, C, and they provide us with the direction number of the vector in R3. Now I'll make a small sketch here to show this part. Rectangular prism is used to represent a position vector. So let's make coordinate system with x, y, and z. Now let us say we have a vector P which is ABC. Now to represent OP, we'll start from the origin. So the tail is at the origin. Now when we say that the components ABC are here as shown, ABC for P, point P, then A is along x-axis. So we move A units, let's say this is my A units towards x-axis. So that is my A component. B, which we are also saying direction number, is the number of units we move along y-axis, right? So let us say B is this much. So we saw that. And C is our component along z-axis. Let's say C is this much. So let's say these are our 3 components A, B, and C. Now as you can see, we will form a rectangular prism and thereby get the position of our vector OP. See how? So first thing is, we move A units along x-axis, that is our x-axis, this is y-axis, and this is z-axis. So we move A units along x-axis, then B units along y-axis. So once we do that, we form the base of our rectangular prism. And then from B, we move C units up parallel to z-axis. So that is, let us say this. And so we reach this place. So the vector which is from origin to this point is vector OP. Do you understand? This is the vector OP. Now to really see it, how it relates to our rectangular prism, let me complete this rectangular prism. So let me go C units up from all our points, right? So if I do that, then see what comes up. So that is the rectangular prism. As now you can appreciate this in 3D. So this vector is vector P for us, and P is at location A, B and C, where this point is A along x-axis, this is B along y-axis, and this is C along z-axis, correct? And this vector is a position vector since its tail is at the origin O and head is at the given point A, B, C. Do you see that? And we call this position as the right hand top corner of our rectangular prism. Do you see that? So that is called the octants. We define this prism with these 8 vertices, and these 8 vertices are also referred to as octants. And major position is P, A, B, C, and the position of this octant here is, it is on top right in front of us, right? So that is the location of our position vector OP in 3 space. I hope with this you get fairly good idea of how to represent a vector in 3 space. We'll explore more about it, and then things will be much more clearer to you. Thanks and all the best.